Hello, everybody. Now we are going to start talking about the methods that we can use to find the change in enthalpy or the change in internal energy after the introduction that we had in the last three videos. So there are two ways to find the values of enthalpy or internal energy, and these two methods are first, which we will start with, is to look for tabulated data. There are tables for some materials that have the values for the internal energy as a function, and enthalpy as a function of temperature and pressure. So this is one option. If this is available, then this will make our life very easy. You just go to the tables, pick the value, and you can use the numbers from the tables directly. The other option is the more general option, which we can use in case of having a material that is not in the tables, or it works also for the tables. It's the general method, which is doing the calculations. So we will see how to do the calculations of enthalpy and internal energy using equations, and this is going to be the topic of the next chapter, which is chapter 8. For the rest of this chapter, we will be focusing on the tabulated data. The tabulated data that we have are for water. Water is a material that has been extensively studied, and we have tons of data about water for different combinations of temperature and pressure, and that's why there are tables. Water is used in industry a lot, and it has been like a very commonly used material for a very long time until now. That's why we have tables for properties of water. So these tables, part of these tables is in the appendix in the textbook. And in this appendix, we have many tables. The first is the physical properties data, the heat capacities. We will use these two in more details, or we will need these tables more in the next chapter, or next two chapters, chapter 8 and 9. Then we have the table of vapor pressure of water. We have already went through this 2 videos ago. And then we have a table for Antoine constants. We also saw this table before. The tables that we are going to be discussing now are these three tables, B5, B6, and B7. These are properties of saturated steam, the temperature table, properties of saturated steam, pressure table, and properties of superheated steam. So what we are going to do now is we will go through the tables just to be familiar with the tables and see how we can use the tables, what information we need to know in order to use the tables and get more familiar with them. So the first table is called the properties of saturated steam temperature table. So we need to remember that when we say it's saturated steam, it means that in the PET diagram, it is this red line, which is the saturation line. And this saturation line is a common line between the liquid and the vapor phases. So it applies for both. So at the same pressure and temperature, we can have liquid and we can have vapor. Because we said before that the phase transition for pure elements or for pure compounds is isothermal. It happens at constant temperature. So if you want to define a specific point on this line, we need to know only one information, either the pressure or the temperature. So one information is enough to know the rest of the information. So if I know the temperature, I can know the pressure, and from the combination of pressure and temperature, I can know the rest of the properties. And this is what we do here. This table, and you need to be careful when you use the tables. You need to make sure that you are using the proper table. So this table is only for this line, for saturated steam. And this table is defined using the temperature. So the information that we know is the temperature, and from the temperature we can know the saturation pressure and the rest of things. So this is what we'll see here. Here we have the temperature in Celsius. And this is part of the table. I just cropped part of it just for demonstration, but the table is more than 2 or 3 pages in the appendix. So you have the temperature, and for each temperature you have the corresponding saturation pressure. And here we have three properties. We have the specific volume, which is the inverse of the density. We have the specific internal energy and the specific enthalpy. For the specific volume, we have, or for each one of them, we have two values, one for saturated liquid, one for saturated vapor. And you see this is a very, very big difference here. This is 10 power minus 3, this is 12. So we have, it's more than 1,000 times the value. Or 10,000 even times the value of the density here, or the specific volume here than here, because water is much more dense than the steam, so its volume per unit kilogram would be less than steam. So this is what we see here. We have two values, one for saturated liquid and one for saturated vapor. The same here for internal energy. This is kilojoules per kilogram. This is the value for saturated liquid. This is the value for saturated vapor. For enthalpy, we'll have three columns. One of the like the cases before, one for water and one for steam, which is this and this. And we have one other enthalpy here column for evaporation. This column represents the latent heat of vaporization, which is the difference between the enthalpy of saturated steam and saturated liquid. If you get the difference between these two, it's going to be the evaporation. Or you add the latent heat of vaporization to the enthalpy of saturated liquid, it gives us the enthalpy of saturated vapor. So this is what we can get from the temperature table. The next table is for the same plot. Or for the same saturation line, but it's called, it says saturated steam. That's why I know it is this line, but it is pressure table. And I think now it's clear that you have the pressure, and for each pressure you know the corresponding temperature, and from the this information you can get the same things. The columns are the same. It's only different from this from the previous table with the information that you know to define the point, once with the pressure and once with the temperature. The next table is called the properties of superheated steam, and when it says superheated steam, it means that it's concerned with this red region, subcooled liquid and superheated steam. So again, in previous tables we had saturated steam, and we see it means steam, liquid and vapor. The same here, it says superheated steam, and it is the non-saturated steam. And it's not saturated liquid and not saturated vapor, so it can be subcooled or superheated. And as you see here, it's not a line as before, it is an area. And for the area to be fully defined, we need to define the two coordinates, x and y. Or the pressure and temperature. So I need to know the temperature and the pressure, and from the combination of both we can know the information about the steam and these conditions. And that's why this table would look different than the tables before. The two tables before were the same, just the difference was, is it temperature or pressure that I'm using to define the point. But here we have the pressure. We have different pressures, 0, 0.1, 0.5, 1, 5, 10, 20. And for each pressure, it says between brackets the Tsat. So for each pressure, you know its saturation temperature. So at pressure 0.5, the saturation temperature is 81.3. At 1 bar, it is 99.6. At 5 bar, it's 151.8, and so on. These numbers are already available in the previous tables. So 0.5 is not here, but 0.5 will be the number directly before this. Is going to be 82 for 81. Here it says 81.3. So this is what we're saying. But let's check 1. So if you check the pressure of 1 at 1 bar, it is 99.6, which is 99.6. And here it gives us the information for the saturated water and saturated steam at this pressure and temperature, of course. So it says 417.5 for the enthalpy and 2675.4. If we go back to the previous table, at 1 atmosphere, it is 417.5 to 1675.4. So it's the same numbers. It's just picking the numbers that fit with the table. So now we can get the saturated liquid or saturated vapor if needed. So we don't need to go back to the previous tables if you're using this table already. So you know the saturation conditions. One other thing that you would see here is, or the important part of the table is what is to the right of this line. Here are the values for the enthalpies, for the internal energy, for the specific volume, which are these three rows. For each row of them, it is the one of the three parameters. It's enthalpy, specific internal energy, and the specific volume. And you have the values. This is all at the same pressure. Each line represents one constant pressure, and you have columns with different temperatures. And this is what we said here, that you need to define two information, the pressure and temperature. And this is the combination of pressure and temperature. The temperature is the columns, the pressure is in the rows. Now the phases that we have are two. It's not only one phase. We can have subcooled liquid or superheated steam, and that's why we have this line, the broken line, that is that separates the two phases, the saturated liquid from the saturated vapor. And of course the liquid phase would be at low pressure, at low temperatures, high pressure. Here we have high pressure, down is higher pressure, and the left is low temperature. So this area would be subcooled liquid, and this area would be the superheated steam. So you just need to go and pick the temperature, the pressure, and you can know all the information that we need to know about the steam. So this is how we can use the tables and the information that we need to know in order to use the tables. Before I end the video, there is something and just two quick points that I want to share with you, which are really important. One of them is about the tables in the textbook. So these are the tables. This is table B6. This is table B5, which is the temperature table. As I told you, it's more than one page, so it's page 1, page 2. And for the pressure table, it is 2 pages, page 1 and page 2. There is just one thing that I want to refer to here, which is an important thing. If you notice the increments of increasing the pressure, it's 0.008. It increases by 0.002. It keeps increasing with this increment until it reaches 0.3, then it's 0.005, and then it keeps going until it's 0.1, then it goes as 0.11, 0.12, and so on. So there is a constant increment of increasing the pressure in the table. But you would notice here that there is the very first number is not matching this increment. So it's 0.00611, and the temperature is 0.01 Celsius. If you remember, the combination of these two numbers is something we mentioned before, which is the triple point of water, where the three phases are present together. The reason we have the triple point as a point in this table is this. The specific internal energy is 0, and the specific enthalpy of liquid water is 0. So having this 0 means that this is the reference state. So the reference state for the internal energy and the enthalpy calculated, or the enthalpy tables tabulated in this table, are the triple point of water, of liquid water. The triple point of liquid water. This is the reference state, and this is very important because we will see next chapter that you can there are cases that you might need to use the steam table with the calculations that you do manually for the calculating the internal energy or enthalpy. And in this case, you need to make sure that the reference state is the same for the two cases, and this is something you need to keep in mind, that this is the reference state for the steam table. So this is the first thing. The second thing is that I have already a steam table here. So what we have is just 2 pages for each of the tables, which is a very small part of the steam table. Just to give you an idea how big the steam tables are, this file is called the International Steam Tables. So it's a book that is just for steam tables. And this book, if you check it here, you would find there are in the table of contents there are a lot of theoretical parts in the beginning about the equations for calculating the properties of water, but here are the tables of properties. You have here, the first is the saturation table, the temperature table, which is the same as what we were discussing now. And then we have a pressure table, but just notice here this is 12 pages. The temperature table is 12 pages. And let's go to page 171 and see. I think I went way further than what I should. So there are a lot of tables here. You see, these are all tables of steam. Here it gives the same thing. This is the single phase region, which means that it's either saturated liquid or vapor, and it gives the pressure of 0.00611212, which is the pressure of the triple point of water. And it gives the information of the saturation, temperature and pressure. And now it's giving us different temperatures, the specific volume, the enthalpy. Then you have different things, the entropy, the heat capacity. So there are way more information that what we have in our tables. But this is a table, so you have another pressure. This is the table for again. This is the table for the single phase region. Means it's not saturated, so it's the third table in the textbook. Now we can keep going, and as we go down, it gives us different pressures: 0.05, 0.05. So you have tables for the specific the pressure that we are interested in. So we have tables, we have a lot of tables. All of these tables are just for the steam at different regions, different pressures and temperatures. Here you will see that there is a set of numbers, and then it says the saturation, which is 285.83 in this case, and then what is above it is the saturated liquid, it's subcooled liquid, and what is below is the superheated steam. And we will keep going. It goes up to 100 bars. I don't know how high the pressure goes, but it goes up to very, very high pressures. It's 800 bars. I told you before, it's extensively studied. So we have information about steam up to 1000 bars. Then we have the high temperature region, which is more than this. It can go up to 2000 degrees. So this is the temperature, the pressures, and all the information. So there are a lot of tables. And then we have different tables. So I don't want to go into a lot of details. I might put this is the tables for the saturation. This is the pressure, and this is the saturation temperature, and these are the information. If we go up, we will find the temperature table, and it gives us here the 0.01, and I think because this is the triple point temperature of water. Okay, so this is the temperature table. This is the pressure table. So these are all tables that are of interest to us. So, anyways, I don't want to go into more details. So this is what we want to mention about this. So next time we will see, in case you have data in the table that is not tabulated. So you have something, let's say, between 100 and 150. How can we do interpolation and get data or calculate data from the tabulated data? So this is something we'll see next time, inshallah. So you see you then. Goodbye.